Hi, everyone, and welcome to SQL Bits 2023. And hope you can see me. I'm Anu from Wellington, New Zealand, and I'm going to present today about how do we use automated machine learning models in Azure Synapse Analytics. And yeah, I'm presenting this session virtually, and it is great to see everyone from here uh, from Wellington, New Zealand without traveling. Unfortunately, I couldn't travel this year, but I'm really looking forward to attend SQL Bits next year in person, and I will get an opportunity to meet you all in person. So hope you can see my screen, and I'm quickly introducing myself. So as I said, I'm Anu from Wellington, New Zealand. I'm a data and AI consultant here. So I work in the IT industry for almost for the past 20 plus years. And if you need to reach out to me post this particular session, and if you have any questions or clarifications, I'm always available on the social media channel. So feel free to reach out to me for any questions or anything. And as I said, I'm a Microsoft certified trainer, so I do run a lot of training sessions as well as a Microsoft MVP for both data platform and AI. My interest is always like how do you take value out of data and present it to customers. And I pretty much run the user groups back in Wellington, New Zealand, and also any events related to data and AI here. So it is great to see you all, and pretty much you will get to learn a few things about what is automated machine learning and what is Azure Synapse Analytics, and if you want to get the best of both, how do you go about doing that? My agenda is quite going to be straightforward and simple because we are going to do a demo around how do we use these two things in a scenario. So what we will start with is I want to introduce about these technologies. So I'm not sure how many of you are familiar with automated ML, what it can deliver. And also you would have had a lot of sessions about an introduction to Azure Synapse Analytics, but I really want to give my spin around what is Azure Synapse Analytics and what is the value that you get out of Synapse Analytics and how does these two services intermingle with each other. So for instance, like if I have automated machine learning, how do I go about using that in Synapse Analytics and what are the advantages I get out of that? So we will get to see that and also a quick demo around how these integrations is going to work. So I'm going to start building everything from scratch. And as I said, I have something I have built before, but I'll be showing it to you from scratch. We'll start building a Synapse Analytics instance as well as automated machine learning instance. And then we can just go ahead and see how we can tie them together and then start loading the data and finalize the demonstration. Uh, Towards the end of the session, if you have any questions, make a note of it, and I'll be answering all of your questions towards the end. So if you have any burning questions, because I'm doing the session virtually and it is getting recorded, so I don't want to interrupt the session's flow with the questions. So just park your questions towards the end. Definitely, I will have 5 to 10 minutes towards the end to take up any questions. So with that note, let me get started with the topic for today, which is using automated machine learning in Azure Synapse Analytics. The first and foremost, I wanted to give an introduction about automated machine learning. So what does automated machine learning really mean? And why did we really need automated machine learning in the first instance? So if you take any organization, right? So they want to create machine learning models, and because this is becoming more and more paramount for organizations, saying, let us do machine learning, and then we can get value out of our data, and we will start using that in making some decisions. And so I always tell a lot of people who want to do machine learning, both from from the technology side of people as well as from the business side of people, is you can't just do machine learning for the sake of doing machine learning. You need to find a problem that you would like to solve. And not all the problems can be solved with machine learning. So that is also, there is a caveat in there. So you have to find the right problem which machine learning can be used to solve. And then appropriately you create the models for that. But where the challenge came in terms of machine learning is about not a lot of organization will have a large amount of data scientists. So you have a data scientist who can help in terms of creating a machine learning model. But again, the knowledge and expertise required in order to create these models, especially from scratch, using Python, is going to be challenging because there may be a lot of problems they may need to solve, but they may have one or two data scientists in the organization. And a lot of cloud vendors, including Microsoft, have noticed this opportunity, but they also found a lot of other like a technical people in terms of developers or analysts who were interested to do machine learning. But of course, they are looking for a better and easier way of doing machine learning. So let me start with an example. So everyone does price predictions, right? So if you want to purchase something, like whether I want to buy a car, whether I want to buy a like a insurance plan, or whether I have to buy any product I want to buy, like there is a sort of like a pricing prediction. So if I want to buy now, what is the cost or price associated with that? If I want to buy in 6 months' time, what is the price associated with that? And sometimes when you are buying things, there is a lot of factors that will be taken into consideration in deducting the price, so or predicting the price. So what are the factors? So if you want to buy a car, yeah, you all know what is the model of the car you want to purchase, the make of the car, and the features that are coming up with the car. They all are important in order to predict the price. And there are similar to that, every price prediction is going to have some sort of factors which is going to influence the price. If I take a real world scenario, uh, I was working for a trading organization, like they do real time trading in this organization. This is a utilities organization in New Zealand. And what they really have to do is they have to predict the price. So, this utilities organization, they used to buy and sell power from the market. So, if they produce excess power, they have to sell that in the market. And they have to make an idea around, okay, um, we have the next 30 minutes to decide on whether to sell the power in the market or not. What is the price is going to look like? So this is where the price prediction process comes into play. So the reason why I'm highlighting is there are some common problems which is consistent across different industries. Not just for price prediction is a common problem that needs to be solved in terms of in an automated, better way. And you don't want a data scientist in every single organization who are going to deduct price, who will be working on that. So what the big players like the cloud providers they now started noticing is there are some common problems which is consistent across domains where we can create the models in an automated fashion. So why can't we leverage these type of use cases and automate the model creation process? And we can provide them to say like these are the algorithms we tried and tested for the use case that you have got, in this case price prediction, and these are the factors that you have fed in with your data. And these are the models that we have ranked based on what we think that is going to give you the uh, value out of those models. So in terms of like accuracy, these are the better models that you can use. So if I have to do this or ask a data scientist in an organization to do this scenario, pretty much they will be spending almost a month or so just on this. And if you calculate it across different domains and things, that is going to take time. So that's where automated machine learning comes into rescue. So you feed the data, you feed what is the target metric that you want to calculate, all the constraints and things, which is basically are the parameters, what is going to influence that particular target that you are going to measure. Then what automated machine learning is going to do is it is going to take the data, take all the features, going to apply the algorithms that it feels that are going to be applicable for that particular data set, and then it is going to train those models. So with automated machine learning, your job is done based on what are you going to predict, what is the data associated, feed into this, and this the center more screen like what I have got in here where the number of iterations and the training scores, this is all done by the automated machine learning. And what you get as an output is saying I have these models and I have ranked these models in the order of their scores of what is going to give you the optimized value out of that model. Then Microsoft Azure is going to rank it for you, but it doesn't mean that you have to follow it. There is an explanation for each and every model. You can go and look at the explanation, and probably you can decide on, okay, so I will use that optimal model that was provided, and I can start testing my data using that. So that's basically automated machine learning, what it is and why it is really important for us to incorporate that. So as I said, when do you really need to use automated machine learning? So especially for people, if you are not well versed in Python, or if you don't want to build machine learning models from scratch, then automated machine learning is your way to go. It is going to save the time and resources, and it is also like going to leverage most of the best practices that we have got in the data science practices, and it is going to apply that. So from my perspective, I would say you can get a developer. Of course, they can put it in, they can just spin up an automated machine learning model, but it takes time to interpret the results. And that's where you can reach out to with the results with your, you can have a discussion with the data scientist that you can see the time, right? If you're expecting your data scientist trying to do all these things in the middle, that's going to take the time. As I said, a month or so. But if you're just going to sit with them and say, okay, these are the recommended models from my automated machine learning, can we just validate is this going to work for our use case? And another thing also to keep in mind is not all the problems can be solved with automated machine learning. So there are some common problems that you can solve with automated machine learning, and some scenarios you can't use it, and you can need to fall back for some common complex scenarios. You may need to fall back onto your uh, data scientist creating models using Python or even with ML Designer. So moving on from that is, on the other hand, Microsoft had a service called Azure Synapse Analytics. So what is the purpose of Azure Synapse Analytics? So before we had Azure Synapse Analytics, did we have anything that is doing the modern cloud data warehouse platform? So if I want to implement a modern data warehouse platform on the cloud, uh, was I able to do that before Synapse Analytics? If of course we were able to do that. We had Azure SQL Data Warehouse, which is actually a data warehouse that we can hold the data with. We had Azure Data Factory, which was helping us to move the data from source to target. We also had Power BI, which helped us with doing analytics and uh, creating reports and dashboards. We also had data lake storage Gen 2. And as you can see, most of the things that we are highlighting in Synapse, we had that even before Synapse. So what has changed since Synapse came? One of the difficulty that we had before Synapse Analytics was like we had all these discrete products. But if you go want to, if we are organization decide I want to do end-to-end analytics, which is a modern data warehouse that I want to build for my organization, what do I really need in terms of tool sets? How do I go and figure out what I require in order to do that end-to-end platform, data warehouse platform development? And that's what we were lacking before Synapse Analytics. In that case, like there is a one-stop shop where you can collate all these technologies, bring all these technologies together, and showcase it to the end user, or whoever is performing the end-to-end data warehouse and analytics, to say, use this platform. It has got all the tools that you require that are available in the same place for you to do the work. And that unification of all these services together in a single stop shop using the Synapse Studio is what first and foremost that we achieved with Azure Synapse Analytics. So now you provision Azure Synapse Analytics. You have the Synapse Analytics Studio. If I want to do start collating the data, cleansing the data, bringing it into like either a SQL pool or a Spark pool, I will be able to do that with the help of the pipelines within Synapse Analytics. Pipelines are nothing but it's similar concept of your Azure Data Factory within your Synapse environment. Same thing, I can leverage, create data lakes using data lake storage Gen 2 within Synapse itself. And I will be able to just to do data classification and consolidation using Purview. And I can incorporate machine learning capabilities with my data, because when we talk about modern data warehouse platforms, they want value out of the data. There is no point in us collating a lot of volume out of data, but without using it for any prediction processes. So the client which I was talking about, who is in the utilities industry, so they pretty much use the historical data, and they use that in order to predict the future. So how do they use historical data with real-time trading, right? So this client I was talking about, they are going to predict the prices to sell power or buy power, and they have to decide on, okay, is this a good time for us to buy or sell the power? So I went back to them and said, like, okay, how do you use historical data? Do you really need past 10 years worth of data in order to make real-time decisions to buy or sell power? So the answer they gave me was fascinating, and because I couldn't really at that point understand why do they need 10 years worth of data, because you can just get last 2 years worth of data or even 6 months worth of data and you can make some decisions, right? Why you need to go that far back, and what is the advantage you get out of it? So the business user I was talking to, and they clearly articulated to me, said, Anupama, yes, that's fine. In a normal scenario, we always predict in future, like 7 days in a future, and we will keep on revisiting the prices as we come close to those 7 days, and we use 7 days in the past, and we forecast 7 days in the future. That's what we really do in a real world trading. But where it is really important to do historical data is sometimes we get into scenarios where there was a major event happen, like major flooding, or you have an earthquake, or uh, the pandemic scenario, right? So this happens, but these things doesn't happen like on a yearly basis or on a monthly basis and so on. So this is an event that happens at some time. When these type of events happen in the future, how does the market is going to react? How does the real time trading platform is going to react? They don't have any references in the last 7 days worth of data for that. So that's when they go back using the historical data, and they figure out, like, okay, what do we really use? How does the market react in those scenarios? They get that information out of the historical data, and they use that for prediction for the future next 7 days or so. Okay, now we have hit with the same pandemic again that happened 3 years ago. How did the market react to that? At least we have some guidance now. This is how the market reacted. We have some guidelines that we can use in order to for our price prediction process, and that is what they really use with that historical data. So the point I'm trying to highlight is that shows how much it is really important, even when they do real-time trading, having access to historical data. It's not that if they don't have historical data, they can't do real-time trading. They can still go ahead and do that, but this is going to give some added information to make some informed decisions. So coming back in terms of, we talked about Azure Synapse Analytics, we talked about machine learning. Now it is all about how do we use them together in order to come up with a solution like machine learning prediction models, or any particular models that you want to generate out of that. So before I jump on to the demo, I want to quickly talk about some of the ML capabilities that you get with Azure Synapse Analytics. And as I said, any ML problem that you are taking, the tool is actually solving one part of the problem. But the key thing you need to know, or you need to come up with, is what is the problem I'm trying to solve. So the business understanding of that. Have we got the data that we require in order to create the machine learning model? So then the data acquisition and understanding of your data is paramount. A lot of people, they think about if they want to create machine learning models, they may put, like, okay, let me put 500 columns worth of data, but you don't need 500 columns worth of data, because all those 500 columns, if we have to use in order to predict your price, that's going to be taking ages for us to get the models. So there are some key parameters, or the key columns that are influential in determining the price of the data. So like the example I was talking about is like, if I want to predict the price of a car, the make, the model, the year of the car when it was came out, all these factors influence the price. Not any other things. A car having 4 tires, is that going to influence the price? I don't think so, because that is the common characteristics of the car. So you have to understand what are the key parameters that is going to influence in the pricing. in that pricing prediction. So keep only those columns that are required in your machine learning models. Just because we have an automated machine learning tool available, it doesn't mean don't feed anything. Still, we have to follow the best practices of understanding our data and just holding on the right information that we require to be fed for these tools. And of course, we'll do the modeling, and also like we will do the deployment of your modeling, and finally the scoring of your modeling, which is all done by the automated machine learning. So let us quickly look at a demo. And what I'm going to showcase is I'm going to start with the empty resource group. And we can go ahead and create. The first step I want to do is if you want to integrate a machine learning, automated machine learning model with the Synapse Analytics, first thing is I need a Synapse workspace. So let me go and look for Synapse Analytics. Cool. So I'm going to go ahead and create a Synapse Analytics workspace. So then you have got the region where you are creating, and we will just go ahead and choose data lake storage Gen 2. And then I'm pretty much going to go ahead and going and creating it here. So while this is creating, so this is the first part, which is we need the Azure Synapse Analytics workspace in order to do our piece of work. While this is happening, also on the other hand, what I require is the machine learning. So I have created this. Next thing is also I need to create a machine learning service model. So let me go ahead and go back to my resource group and go and create here and just say I want to just create a machine learning model workspace. So I'll keep it here. So I will say, so if I put it 2023A, cool. So one of the thing that happens automatically when you provision a machine learning model or machine learning workspace, uh, it automatically will create you a storage account. The reason for holding a storage account is this is a default storage account where you can load your files and everything. But normally, a lot of organizations will have their own storage account where they already have a data lake storage where they have all the files available. So it is mandatory that you create a storage account, but it doesn't mean all the files need to be here. You can still have a storage account external to this that is holding the files, and your machine learning workspace can connect to your other storage account and pull the files and use it for processing. It automatically will provision a key vault also, because if you want to hold any sensitive data, it will be held in here. Application insights for monitoring and container registry. If you require, you can create one in order to hold any images that you require. That's mainly for deploying your models, right? So that one you can use it you can create an image of that and hold it in a container registry. So let me go ahead and create a machine learning workspace. So they both are in the deployment is in progress, and once the deployment is done, then what we will be able to see is how do we link these two things together. So let me go ahead and create this. Cool. So while these two things are happening, what I have done is I have already created a resource group which contains all these resources that we created. I want to showcase it from scratch, and while this is happening, we can quickly check it here. So I have Synapse Workspace, and I have a Synapse Studio, which I can open. So just bear with me. Sometimes when I try to open these things and when I share my screen, it takes a little bit time longer than what I used to see. And let me drag it here, get that opened, and then pull it back there. So what I'm trying to do here is I have already provisioned an Azure Synapse Analytics workspace. Here you go. So you have the workspace already available. And as you know, within Synapse, one-stop shop to do everything. So starting from if I want to uh, collect the data and if I want to build notebooks in order to consume the data, uh, integrate the data from disparate data sources, and then finally, if I want to spin up any Spark pools or SQL pools, I can go ahead and do that. So what I really did in this scenario is I created a Spark pool. And basically, like I said, I'm going to just use the Spark pool in order to collate all the data that I require and store it into a Spark table. Let me get back to here. Yes, it's done. So now this is my Synapse in an instance I created. This is the blank one, which I provisioned as part of this session. So I have made a suffix in here. If it is just without the A suffix, then probably that is the one I pre-built. If it has a suffix, then probably this is the one I'm building as part of this session. Okay, so coming back here, so I can go to manage and I can say, okay, spin up a Spark pool. And I want to say like a demo Spark pool. And I'll use this. I'll use a small VM. I don't need an auto scale capability right now. And any additional settings, I can check that. I don't think so. I need it. Cool. I will go ahead and create this. So this is actually creating a Spark pool. While this is also happening, what I can do is I have a notebook which is actually has some data that I want to use in here. So what I'm going to do is like import that notebook in here. So let me go here and say import. So I'll pull the file. 1 second. So I got a notebook to create a Spark table. So as you can see here, I think everyone know what a notebook is, and I'll quickly outline it and I'll keep moving on. So notebook is a really cool tool which I use, or most data scientists use it in when it comes to creating machine learning models or any data cleansing processes with Python or R. The advantage you get with notebooks is like you will have the code, the instructions, and the output all in one place. So historically, what we used to do is we write instructions in Word document, then we'll have Python scripts, and then we'll say, if you run script 1, 2, and 3, you will get to see this output, and the screenshot will be in the Word document. Really hard to follow through, but here I will have instructions in here, how to prepare and feature the data. You can put the instruction here, and also you have the code here, and I can run the code and I can also see the output here. So if I have to run this Spark pool, basically I need access to the demo Spark pool. So because I need to attach the Spark pool in here. Cool. So I can just go ahead and now I can run this piece of code. This is going to go ahead and create a Spark table with the trips data I have got. So let me go ahead and run it. While this is running, let us quickly check how is our machine learning service looks like, and it got created also. And one of the thing I would like to do is now we have to integrate Synapse with the machine learning workspace, right? What we have got is basically there are two services. They are standalone sitting there. How do I make my Synapse Analytics to talk to the Azure machine learning models? So in order to do that, first thing we need to make sure is like we have to create a what we call it as machine learning linked service in Synapse. So if in Synapse, what you can do is you can go ahead and create a linked service. Linked service is basically saying taking these two services and linking them together. To do that, Synapse should be able to talk to the machine learning workspace. So for that, we have to give some basic permissions. We start with access control. I'm going to go and add a role in here. And so what I'm going to say is, okay, let me go ahead and add a role. And in order to add a role in here, I would like to just go and figure out, I want to give a contributor access and next. And I want to use managed identity in order to establish the access, and here I'm in here I want to just do okay, so I have to do Synapse Workspace, because what I'm doing is I'm saying, okay, I'm here on the machine learning workspace. I need to give Synapse access to this machine learning workspace. I have multiple Synapse instances. So here I'm going to use the 2023A and say this particular machine learning instance can be accessed by this particular Synapse workspace. Let me go and give the permissions. So now I'm adding the contributor role for my Synapse account to this machine learning workspace, which means they can start interacting with the data. So once that is done, now I can go back to Synapse. I can happily see my Spark session is starting in this point. So the Spark session has to run, which is going to run all these, which is going to run all these scripts, and then it is going to create a table for me. But while that is executing, I can quickly show you what is the table that is going to be created. So this is the table that gets created and all the columns that are imported from the file that I provided and for the notebook to execute. And then once this table is created, right, now I can go ahead and say, I can go ahead and train a machine learning model quite easily with that. So here, this is my train a new model. I can go ahead and do that. So, but as I told you before I can do this part, I have to create what I call it as a linked service. So if I go back to my Synapse instance and go to manage, so I have a Spark pool already, but what I need to create is link service. So as you can see here, I have already created a link service called Azure ML service. So this is basically telling Synapse, you need to go and talk to this particular machine learning workspace. If you want to run any automated machine learning models, I want you to execute on this particular machine learning workspace. And this is what the link service basically does. It's basically establishing that link between your Synapse workspace as well as your machine learning workspace. So here it's still running and trying to create the table. So now, because we have all this already configured, the next step, what you will be doing is once the Spark table, the data is ready, you go ahead and say, I want to create a new machine learning model. You click on train a model. If you have done machine learning in Azure Machine Learning Workspace, right, you would have seen this in a standalone mode. So let me go here to show that. So this is what you see in the Synapse interface, right? You Let me go back again. So this is my table. I click on the table and say I want to create and train a model, and I have my automated machine learning workspace or machine learning model wizard is here. If I want to do same thing without Synapse, think about I want to do automated machine learning without Synapse. What I do is I go back to my machine learning workspace, launch my machine learning studio, and with this machine learning studio, I go to automated ML and I say I want to create a new automated ML job. You go and select the data set, and then what you do is you will get to see the same screen. This is good. So now it is actually reading the data because the Spark pool has pinned up. As you can see, the notebook is getting executed and it is now running to save that data into a Spark table. So this is happening in real time, but what I'm progressing is the another instance where the table got already created. So this is exactly what you see in Synapse in the integrated fashion of automated machine learning. You can get that in the Machine Learning Studio in a standalone mode also. So here I'm going to choose regression model for this use case. And I'm going to say this is the workspace you should be using. And the column I want to predict is the fair amount. And yes, you can use this Spark pool for the same thing. So now I can continue. And I have got everything done in from a regression model perspective. What is the primary metric I need to calculate and how long I'm going to leave for the job to run, and also any concurrent sessions I need to run. So there are two options in here. One is you can immediately create the run. So you can say go ahead and create the machine learning run from here. Or the other option you can just say is just open this experiment, creating the machine learning model, in a notebook. So in a notebook, if you want, you can go ahead and do that. So that will be good because then you can reuse it, right? So what you can say is, you can just say like, okay, I want to run it or open this in a notebook. Now this is going to open the information in a notebook so that you can just trigger the process. It will come through. Just give a sec. Because sometimes, as I said, when I share the screen, it takes a little bit of time. Well, let me get that back. I'll get it in here. So basically, what we are doing is this is now going and initiating a auto ML run. So this is going to go and create an auto ML run, which is going to take some time for it to run. So the point I wanted to highlight is that we are not going to just go and see how it is going to go and create the models and stuff. The main thing is around we started to see how it integrates well together. So we had a machine learning model. We are workspace we provisioned a Synapse workspace. We loaded the data into a Spark table. Now the data will be available in here. Just I need to refresh. So when I refresh this data, now I can see the lake database and I can see the table got created. So if you look at it, this is the instance that we have been using in our demo here. So now you can go ahead and do the same thing what I did before. Data is got imported. I can train a model and choose it. I told you like you can't solve everything with automated machine learning model, right? Like you can, there are only certain things that you can do. So you can do classification type, solve classification type of problems, regression, and time series forecasting. These are the three things that you can currently do. Because as I said, automated machine learning is there not to solve every single problem. This is for common problems that are across the domains that you can use to solve with automated machine learning. So that's one of the key thing to understand here. So if you have a machine learning like a problem which where you can't use either classification, regression, or time series, straight away you can cross it out to say it's not automated machine learning. Either I need to use the Python SDK or I have to use the ML designer for that. Or otherwise, you can go ahead and choose this, continue it, kickstart what you want to estimate, and then you can go ahead and say like, okay, I want to create my machine learning model. So in this case, I have a Spark pool that is available. One second, did I choose the right one? So provision process done. So I'll quickly check in here whether my tools are available. That's right. Let me get the screen here. So what I'm looking at is to go ahead and create the model. So sometimes I need to refresh it multiple times just to get that because I had a Synapse workspace that's already available. So let me relaunch that workspace again. Just give me a sec. So while I do that on that, so but the existing model is still actually running it. So this is going to take 3 hours or so. I'm not going to demonstrate that for 3 hours in here, but just to highlight to say like how you can link these two models together, give the data, give select whether you want to do classification or forecasting or going to do regression, and then you say what is the column that you want to predict in that data set. What automated machine learning is going to do is it's going to run in the background, spin up the models, and it is going to bring the data back. And so basically, the data is nothing but, as I said, the ranking of all the models ranked in the order of which is the optimistic model that you can use, that is going to give you the better results. Then once the model is available in Synapse, now you can start using the model with the large volume of data that you're going to hold in Synapse. You can use that for training and as well as you can use it for a testing purpose. So that is pretty much what I really wanted to cover in that demo. It's more or less showcasing you have two independent services and how can you bring those two independent services and link them together with Synapse, where Synapse being the one-stop shop now that has got the capability to bring in the automated machine learning capabilities inside Synapse. And whether you want to run machine learning in an automated way or whether you want to run the machine learning model in like in an automated way within Synapse or outside Synapse, you will be able to do that. Let me get back to my slides. Yeah, so we saw a quick demo of how we can build or how do you integrate machine learning, automated machine learning with Azure Synapse Analytics. What I would like to do is want to quickly wrap up and then I'm happy to take up some questions. We have another 10 minutes to take up any questions. The key point I wanted to just highlight is, as I said, machine learning is automated machine learning is cannot be used for solving every single problem. It is mainly used for common problems like regression, classification, and time series forecasting. And you can do automated machine learning in a standalone. You don't need Azure Synapse Analytics to do automated machine learning. But if you are using Azure Synapse Analytics as a single stop shop to build your enterprise or your data warehouse platform on the cloud, then probably you can leverage the integration between Synapse and automated ML within Synapse Studio itself, and you can get the machine learning models to be utilized with your data. So uh, keep that in mind. A lot of things that you can do within the Synapse Studio. What I did with machine learning is scratched the surface of just introducing you how to do or how to utilize automated machine learning in there. But what you will also notice is like if you want to do cognitive services, if you want to include cognitive services inside your Azure Synapse Studio, you'll be able to do that. So in terms of if you want to do like computer vision or if you want to do like a fraud detection and are anomaly detection, so these things can be also integrated within Synapse Analytics. So it's not only limited to automated machine learning, but anything that you can do outside Synapse, now there is a capability to integrate that service within Synapse with all the data that you are storing in Azure Synapse Analytics. So I will open up the forum for any questions related to this topic for now. So anything that I covered, like if you have any questions, feel free to ask me, or anything in general you want to know about Synapse or how you use automated machine learning in there.
Hi, Anupama, it's Andy. Can you hear me?
Yes, I
Hello.
can.
So firstly, Ben Weissman wanted to say hello, and he hopes to see you soon.
Yes, I'm missing. Yeah, that's right. I'm missing being in person there.
Yes, yeah.
Hi, Ben.
So we've got a question. I'll try and do it justice. How do you install additional Pi libraries on Synapse Apache Spark clusters, Spark pools?
Okay, so what you can basically do is, let me get in here. So just what you can do when you do the manage, let me get in here. Just give me a sec. I'll get data flow libraries and cool. Just give me a sec. I'm just trying to find out. It can be done through here, but I'm just trying to figure out where I was doing it. So when you actually create Spark pools, and probably there is a way you can import specific library configurations and stuff in here. Let me do that as part of, I'm putting a new pool in here. Yeah, there you can have packages. You can, when you are provisioning the pool itself, you can go ahead and specifically mention like what are the type of things you need to do. So whether it needs to have support for Python, what version of Python or any languages that you want to use to run the notebooks with using this pool, and the packages that you want to just import, you can enable them through here. So these are any session level packages in addition you want to import it inside the pool. So did that answer your question?
I hope that answers who asked that.
Okay, cool.
And so we've got a second question. Can you work with unstructured data like JSON or XML?
Yes, definitely. So when you talk about unstructured data, you have the data lake storage exactly for that reason. So when you noticed when I go into data in here, so I have got a lake database that got created, and you can hook up, as I said, you don't need to have the data inside Synapse. You can have within Synapse, like you can have a data lake storage, and then you can hold your unstructured data in there. So if you have a large volumes of JSON files, store it in your data lake storage Gen 2, which can be provisioned within Synapse, and you can have those files loaded in here, which can be used in your advanced analytics. So the answer is yes.
Brilliant. And we haven't got any more questions that have come through. Thank you.
No issues. And I think these are great questions because it's just starting to showcase what are the things you can do with this. One of the thing they have also introduced a new with Synapse, which more recently they started did that. If I go back to the slide in here, what we call it as these are the analytical runtimes they had in Synapse like SQL and Apache Spark. Now they have introduced a Data Explorer. So Data Explorer previously, if you remember, it is a separate service that we had on Azure, like Azure Data Explorer. And if you want to do a large amount of analysis over telemetry data, so because we have a lot of log files and things that are coming, and we want to just get insight out of that telemetry data, we were using Data Explorer for that. Now they have bundled the Data Explorer within Synapse. So what it gives the capability is store your log data in Data Lake Storage Gen 2 and leverage Data Explorer to do your analytics over telemetry data. So it's really cool to see. The reason I am highlighting this is the foundation where you can store all the data for Synapse is your Data Lake Storage Gen 2. And of course, you can spin up Spark pools or SQL pools or even Data Explorer pools now if you're dealing with telemetry data. And of course, then over that, you can start building your machine learning capabilities over the data, or you can just start exposing the output of that data into tools like Power BI and any other reporting tool. So watch the space. The reason I highlighted is this is new, and you may have any other new capabilities that will be coming in Synapse. So Synapse is still growing as we speak. Cool. I think if there are no other questions, I just wanted to say thanks everyone for attending the session, and thanks SQLBits for giving the opportunity to present virtually this year. And this is my first SQLBits session, and I was quite excited. Unfortunately, as I said, I couldn't be in person, but I'll definitely look forward to be in person next year. And thanks everyone, and I'll see you at a later point.